In this video, we're going to address the idea of choosing the right financial formula. So hopefully you've gone through all the material in Chapter 6, the material about the financial math and which formulas to use in which situations. And in this brief video, we're just going to talk about some sort of flags to help you choose the right formula. So when you see this on the test, you don't have to memorize all of these formulas. Some of them are pretty complex, but you do need to know how to identify which formula to use for which problem. So let's go ahead and start. And I've copied down all the financial formulas that you will be given on the test, and this is how you'll see them. Okay, so note that I don't tell you what S is, what P is, what R is, what little m is. So you'll be provided all of this information, but you have to know which one is which and when to use them. And we'll go over that in this video, of course, but I just wanted to give you a sense of what you will be able to see on the exam. So you don't have to memorize any of these. They'll be given to you. Now let's talk a little bit about how to use them. So first one, if $300 is invested at the end of every month in an account that earns 6.5% interest, how much money will be in the account after 11 years? Okay, so there are a couple of things that can help point you to the right formula. In particular, the fact that money is being invested every month, right? Specifically the end of every month, but every month, more than one time. Okay, that immediately points to one of these two, right? These are now our only two options because every other formula in this list is not for something with a recurring investment. So remember, the capital R stands for like monthly payment, and the reason it's an R is because it's recurring, okay? Now, when I say monthly payment, it doesn't have to be every month. It could be every 6 months or every week or whatever. But the R stands for recurring. So on all of these, you just put some money somewhere and then never touch it again, as opposed to investing every month or every year or every week. So we know it's going to be one of these two. And then you just have to know what these two formulas are. So this first one is for investing, like when you're investing in an annuity, and this one is for paying off loans. That A stands for the original loan amount in this formula. So it turns out this and not this is the formula we're going to use. Now, I'm not going to work these problems in detail, but I am going to just sort of describe how you would go about working them. Let me get my black pen. Okay, so S R, little r, m, t. Here are all our variables in this expression. So S is future value. That's what S stands for in all of these equations. So how much money will be in the account after 11 years? We don't know. That's what they're asking us to figure out. What's the future value? Okay, capital R, as I mentioned before, is your recurring payment. So what's our recurring payment in this problem? The $300 we're investing every month. Okay, so that's going to be 300. Little r is always the interest rate as a decimal. So our interest rate is 6.5, which means that our interest rate as a decimal is 0.065. Let's go ahead and skip and do t. So t is always time in years. Here that's listed, 11 years. And now let's talk about little m. Little m is the number of compounding periods in a year. And you might notice that we don't see that explicitly listed in this problem. And that's because in annuities, however often you're making your recurring payment, that's how often the interest compounds, always. So because we're making an investment every month, that means our compounding is happening every month as well. Okay, so here the number of compounding periods is going to be 12. And then if you plug all this stuff in, I'll go ahead and tell you the answer in case you want to check this out for yourself. But the answer ends up being $57,613.64. So if you want to try working this problem, and I suggest you do, here's how you read off all the information. This is the formula you use, and this is the answer you should get. Okay? And in particular, the flag that you should look at for this particular problem is the fact that money was being invested every month. That immediately eliminates all but two of our equations. Okay, let's go to the next one. This problem in orange. So suppose $1,200 is invested into an account that earns 4% simple interest How long will it take until the account has $1,700? Okay, there's one flag for this problem. Just like last time, there was a sort of flag that told us the right direction, and last time it was the fact that we had multiple payments. So you can see this time we don't have that, right? It's just $1,200 being invested at some point, and we never put any more money in it again. The keyword for this one, let me get my green pen back. The keyword for this one is simple. Okay, simple interest. There are not many equations that involve simple interest here, right? This is compounding, right? This is compounding periodic, this is compounding continuous, this is compounding, and both of these are APY. So it's these two formulas. These are the only ones that apply to simple interest. This one is simple interest explicitly, and this one applies to everything. So we're going to need both. Okay, we're actually going to need both of these to solve this. So our unknowns are S, not S equals P, S, the future value, P, the principal amount, and then capital I, but capital I is equal to P times little r times little t. Okay, so here are the four variables, right? P plus P times RT if we substitute in for I. So here are our four variables. So future value, do we know the future value? Yes, it's going to be $1,700, right? How long until the account has $1,700? Principal value, the original investment was $1,200. Interest rate as a decimal, 0.04. And then T, that's what the question is asking us. How long will it take? Okay, so we don't know T. And again, if you want to try this, when you work this, you should get 10.42 years. Now here I've just rounded to two decimal places. You'll get rounding instructions on a problem like this if you see one on an exam. But here, for convenience, I've just rounded it for two decimals. And that should be plenty to tell you whether or not you're doing the problem correctly. Okay, so again, the flag here was simple. You see the word simple? It has to be these equations, and that's it. Okay, let's go on to the next one. Suppose $5,500 is invested in an account that earns continuously compounded interest. After 6 years, the account has $7,820. What's the interest rate on the account? Okay, so we don't have our two previous flags in this one, right? We don't have a recurring payment. We just have $5,500 invested one time. And we don't see the word simple, right? This is not simple interest. It's some kind of compound interest, which is what most of our problems are. However, this one is continuously compounding interest, okay? And that is the flag we want to look for this problem. So continuously compounding. There are only a couple of formulas that have to do with continuously compounding. Could be this one, or could be this one. None of these other six have to do with continuously compounding interest. Okay, so again, it comes down to knowing, do you know what this formula is supposed to mean? Do you know what this formula is supposed to mean? This formula is for annual percentage yield on continuously compounding interest, which is not what they're asking us about. So this one gets thrown out, and this is the formula we're supposed to use. Okay, so our unknowns here are S, P, R, and T, because remember, little e is not an unknown. That's just a constant like pi. So future value, do we know the future value? Let me scroll up a little here. Do we know the future value? Yes. We want to know how long it's going to take, but in the end, after 6 years, it has 7820 in it. So that's the future value. The principal amount was $5,500. The interest rate as a decimal, that's little r, that's what they're asking us about, right? What's the interest rate? And so T, time in years, ends up being 6. And again, if you want to check your work and try and do this problem, and I suggest that you do, the answer you should get is R is 0.05866 if you round this. And that might seem like a lot of decimals, and that's because usually we write it as a percent. So 5.866%. And again, I didn't give you rounding instructions in this problem, but on an exam you will see rounding instructions. But this should be plenty enough to tell you whether you're doing the problem correctly or not. So those are some of the flags that you want to look for. And in general, you just need to know what these things represent, okay? And there's a handout that you'll get on the website, on the course website, that tells you what each of these is used for. But basically, these apply to simple interest. This is periodic compounding interest. This is continuously compounding interest. This is an annuity where you're earning money. This is paying off a loan. And then both of these are annual percentage yield formulas. And it just depends on whether you have continuously compounding interest, that would be this one with the E in it, versus periodic compounding interest. Okay? And just to give you a sense of what you can expect, any of these problems would be totally valid test problems. Okay? So you need to know how to do these problems with no sort of guidance. So hopefully that helps clear things up about how you choose these formulas, and in particular, what to look for. Okay? Recurring payments means one of these two. Simple interest means these. Continuous means it has an E in it, right? And then the rest of them, you just have to sort of know what you're doing and choose the correct one. So hopefully that's helpful.